Okay, we're going to have Ken, one of the students, explain problem 1 to us.
So problem 1 says that an egg is being dropped from a height that has been given, right? So whenever an egg is being dropped, what is the initial velocity? When you drop something, it's going to be 0, right? So we know by our initial velocity, we're trying to find the acceleration. So acceleration, as it's given here, this is the formula. Acceleration is the change in velocity, which is the final velocity minus the initial divided by time taken, right? So, but what is our initial velocity? 0. But they gave us our final velocity, right? 11 meters per second. True. And did they give us a time of fall?
1.12 seconds.
1.12 seconds. So that's just why we did the final velocity, which was 11.0 meters per second, minus the initial 60 started at 0, divided by the time of flight. So this is the acceleration. And it's basically, you look at that, it's 9.82, it's pretty close to 9.81, the acceleration due to gravity. So now, case B, it's like, let's say we're on the sand ground, on the ground made with sand. So once you throw an egg, it's gonna get into the sand, right? So before it starts getting into the sand, before it hit the sand, it has an initial velocity, which is this final velocity, right? So our initial velocity in this case is gonna be our final velocity of the other case. So our initial velocity, VI, is gonna be 11.0 meters per second. Now, once it's going into the sand, which is decelerating because the sand opposes a force on it, for it to stop, when it's going to stop, it's going to have what velocity? 0. So the final velocity at that time is going to be 0. So acceleration is still the same thing, change in velocity divided by time taken. And they have given us the time for it to decelerate and stop, which was 0.131 seconds, right? So we have acceleration, change in velocity divided by time taken. Final velocity minus the initial. The final, since it stopped, was 0. And the initial, when it started entering the sand, which is 11 meters per second divided by the time. And when you divide that, you have this. Retardation is the same thing like deceleration. That means it's been decelerated and gets to 0.
And also it's a negative value.
Right.
So that's excellent.
That was good.
That was an excellent. Let's include the applause as well. All right, now let me stop it.